trigonometric functions of sum and difference of two angles. So starting from this video, we're going to learn to derive all of this set of formulas. Everything is interconnected. They are simple. So you guys don't have to get worried that there are a lot of it. Since everything is derived from everything, it's quite simple actually. So the very first thing that we need to learn is this proof. So cos of x plus y is cos x into cos y minus sin x into sin y. So we are looking at two angles. It is x and y. So let me draw x. So say that's x. And the angle forms a point over here, right? Point P, or yeah, point A is what I'll call. So this will be cos x comma sin x. Agree? Because this is x. This we have learnt. Now I'll extend this angle. So we are looking at something like this. And now I'll join this. And that's your angle y. That's your point. Say that's point P. And now this would be what point P would be of the coordinate. Yes, cos of x plus y, because we always measure from the positive x-axis. Okay, if this is OD is a positive x-axis, and from there the entire angle is x plus y, and so this will be cos x comma cos of x plus y comma sin of x plus y. Okay, and now one last angle we need to complete the figure. That would be minus y. So again I'll join this and all of that, and we have this angle to be, say, M. So this would be cos of minus y comma sin of minus y. Okay, so that would be your point M. So there should be no confusion, right? Very clear cut diagram. Now the next aspect is to join point D and P and M and A. So point D over here is 0, 1. Agree? Or 1, 0. It is 1, 0. Okay, so now the diagram is completed. Almost. Let me do one last thing. I'll call this angle with some name, and that would be theta. So this angle is POM. I'm calling that as theta. Okay, now let's start off with the proof. The next part of the proof. This is your diagram. The next part of the proof is to prove congruency between two triangles. Which are those two triangles? Consider triangle AMO and triangle OPD. Okay, so in this, what is that we are looking at? We are looking at OA. Let me change the color. OA is equal to OP and OM is equal to OD. Why are they equal? Because of them being the radius. Now, other than this, what else can I tell? I can tell that angle AOM is equal to angle POD, which is equal to y plus theta. So you might ask a question, so how is that, we have y and theta over here, that makes up AOM, that's okay. When it comes to POD, is it not theta minus y? Well, the thing is, when we talk of minus y, this thing is to do with direction. This talks about direction and nothing else. So if I talk in terms of magnitude, right, over here, if I talk in terms of magnitude, plus theta is equal to magnitude of minus y plus theta. So in this way, the angles are equal. So with all of this, what can I conclude? So with this, we can tell that triangle OAP is OAM actually is congruent to triangle OPD. OPD by which congruency? SAS congruency. So with all of this information, we can conclude one more thing. You can tell that AM is equal to PD. So from this, by CPCT, AM is equal to PD. Okay, and now the next part. So with this in mind, what we can do is we can square both the sides, like PD square is equal to AM square. I just flip the variables around, nothing else. And I'm going to use distance formula. See, these are nothing but coordinates. Remember, unit circle is drawn on coordinates. So I can use distance formula derived from your coordinate geometry. So if you guys remember, it is x2 minus x1 the whole square plus y2 minus y1 the whole square, and this entire thing is taken for a root, right? So that's your distance formula. Okay, what is PD? If this is x2 and this is x1, so we have cos of that value minus that square and all of that. So let me write it. Cos square x plus y minus 1 square the whole square plus sine square x plus y plus 0 square, right? Sorry, yeah, my bad, this is not a square. Now cos of x plus y minus 1 the whole square plus sine plus 0 sine square of x plus y. The reason being over here, because we have 0, so I didn't write it, but yeah, if you guys want, we can write it, not an issue. And then the next is on the RHS. So we have cos x cos of minus y and sin x sin of minus y. So here too the same structure, not a big deal. So this would be cos of x minus cos of minus y, remember, the whole square plus sin of x minus sin of minus y the whole square. Now the thing over here that we have to look into is, because cos of minus y is equal to cos y, right? Where does it come from? From this. Of course, we have shown the derivation before, we have learnt it. If not, you guys have to learn this and come back. And sine of minus y is equal to minus 1 into sine y. So I told you guys when I was deriving this that this is going to be used everywhere, so you can see the usage. Now with this, what can I conclude on the RHS? So the RHS term will become cos of x, this will not change, while this will become minus cos of y the whole square, okay, plus sine of x. So sine of minus y is minus of sine y, so minus of minus is plus sine y the whole square, okay. And now we have the entire expression. I'm going to expand using a minus b the whole square and all of that. So this is a square plus b square minus 2ab plus we have the second term sine square of x plus y, right? And this is equal to the RHS cos square of x plus cos square of y minus 2 cos x cos y, right? And then we have plus sine square x plus sine square of y plus 2 sin x sin y. Okay, and now we have to use the following formula: sine square of theta plus cos square of theta will be equal to 1, is it not? So sine square of x plus y plus cos square of x plus y plus sine square of x plus y is equal to 1, while we have cos square x sine square x equal to 1, and then we have cos square y and sine square y. I'm trying to think of, okay, I think I'll just do this. Yeah, this two will add up to 1. So we have on the LHS 1 plus 1 minus 2 cos x plus y, which is equal to, and on the RHS we have 1 plus 1 minus 2 cos x cos y plus 2 sin x sin y. Right, so 1 and 1, 1 and 1 will get cancelled, and we are left out with minus 2 cos of x plus y is equal to minus 2 cos of x cos of y plus 2 sin of x sin of y. And at last we can dividing minus 2 on both sides. So each term has to be divided. So 1, 2 and 3, there are 3 terms, and all of that has to be divided. So we have cos of x plus y is equal to cos x cos y minus sin x sin y, and we are done with the formula. That's it, right? Well organized and a neat manner, you are able to derive this formula. And once you have this formula in mind and you have a definite idea about how we got it, every other formula will become simple. Okay, one last time, consider the angle. Don't miss out that this is cos of x plus y plus, not plus, comma, sin of x plus y, right? And minus of y is same in terms of magnitude as y. And so all of this put together, we have these two triangles to be congruent, and so these two sides to be congruent of same length. And so on squaring using the distance formula, so this square and square root gets cancelled, and all of this you guys have learnt in 10th grade, substitution, and this is a fact that we're going to use over here. And RHS becomes this, and on expansion and using this formula, you'll end up with the answer. Okay, so now pause and have a look at the answer.